PGC quality and programming style. I don't know why these very philosophical sort of or fuzzy subjects always land on me, but this is where you are. So let's dig into this a little bit and see how it connects together. What is PGC? Parametric graphical configuration. It's a term that we have created at Configura to try to differentiate what we do, because we do not think we are CAD or just a drawing tool, or we created this term to differentiate us from that and say we are different. And let's try to see or talk about what it is. And I wrote this a long time ago, and I put a big cross over it. PGC is a solution development framework for implementation of quick, efficient, and intuitive graphical configuration software customized to a specific product and solution domains. Beautiful, but academic. Take it out. So let's go for something that's comprehensible, sort of. Few keywords. Flowing ease is key. So if you know, how do you know something is PGC? If you've done your job right in CT Designer, well, you should be able to work with the components, the products, whatever it is your task at hand, with a flowing ease. There should be no constraints. You shouldn't feel like you're restricted by the software. It should come naturally to you. That's what it means. Touch and feel, that's really the way to evaluate. It's a quality aspect we're talking about. PGC is all about quality. Touch and feel, you say, I put the grass there, because grass is so evocative of emotion when you touch grass in the spring, right? And this is exactly what you have to do. You have to sit there and forget everything you know and just see how does this feel. I pick this icon, I bring this out, with the basic gestures that we have, and does this react in a way that I feel is reasonable for the product? Does it fit the behavior that I would expect from such a situation? How about direct manipulation? Why is that there? It's so popular for some reason for software developers to pop up a dialogue for everything. A dialogue is disruptive and unnatural, right? And even worse if it's a modal, because then, oh, I want to bring up this other information here to see that at the same time. And then the system goes bling, bling, bling. You have to answer this question first. A dialogue is usually kind of incomprehensible. It has a number of choices right in there, and some text. And you're supposed to understand if you click or check some marks, do some selection, that you're going to get a certain effect. If you have 10 choices, how many combinations are there? How comprehensible are the effects? Compare that to just pointing in the drawing and, for example, taking the little rotation marker and just pull it, and it immediately starts to rotate. This is, if you go down the list here, explorative, so you can just go on with simple natural gestures, do trial and error, and it will react and show you what it does. So it will teach you how it works. This is really fundamental as well. And we really want to interpret these basic gestures. So how did these ideas come up from the beginning? For example, one thing I think that's been partially lost is you click something out, like 1, 2, 3 cabinets, and when you start to get very quick with this, you click, 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 and it becomes a click drag. And then it's just a natural feeling that, why is that static? Why do I have to do that and go out and drop the current one and then go stretch it? Why can't I just immediately accelerate and get the stretch from that gesture? Because when I start to move quickly with the cursor, that just comes as a natural gesture. So that's why we created that from the start. It came naturally. Assist means if you have, for example, a corner of walls and you have a corner cabinet, then it's very, very strange if the corner cabinet just floats across and all over the place and it's not aware of the corner. But if it jumps into place in the corner, that's assisting the user with a typical task that you would do. It doesn't really make sense to place a corner cabinet in most scenarios in any other place than in the corner. So help him with that. Remember all input. This is one of my passions, and I know it's very often forgotten as well. I mean, if I give the system some type of information, I want it to remember that. If I change something in an animation property, so I get a bigger width. Then the next time I pick the same cabinet, I want the same width. I don't want to repeat myself. I already said this is my current default. So yeah, sometimes you can have a settings dialog, so you have to go to the settings and you set up your default for the session. It's useful in some scenarios, but it's even better if you just catch it on the fly and make it happen. Because you bring out your cabinet, you type in your width that you want to work with, and then, no, I forgot, I have to do this first. And you bring out some helpline or something, you go back, you pick the cabinet, and the width is forgotten. Isn't this annoying? I'm an enormously impatient person when I sit with computers. They're supposed to help me, not the other way around. When I go out and have lectures for university students about programming, my first question is, why do we program computers? And I'm usually just met with dead silence. Isn't this fascinating? I mean, there's a class of 120 students just studying programming, and they have no answer for this most basic of all questions. Referring back to the Hitchhiker's Guide to the Galaxy, they define a robot as a mechanical apparatus meant to do the work of man. And that's very much what a computer is. It's a robot, but it doesn't have feet and legs, It does mechanical things, and it's there to assist us. We should not, humans are so adaptable, so it's very natural for us to adapt to a computer, but it's the wrong way around. We should make the computer adapted to us, not the other way. Explorative and encourage experimentation is just this. Do direct manipulation, see what the effect is, be forgiving, and give very, very nice and understandable feedback to the user. So you want to show all types of manipulations that have an effect on a product, for example, has to be visually apparent. And then you understand the effect of a specific manipulation or setting that you do, because it's going to just happen in front of you. And then you can play with this until you get it. So usually if you come in with less experience of other CAD tools, you're going to do this better if the application, the customization layer is done correctly, the extension. So let's move on a level. So what does this get us? If you think about what we do, is typically that we look for commonalities in products. So instead of having an icon for every width and every variation of a specific product, like a straight table, we just condense it into a single icon. So there's a single choice for it. And this gives you a more condensed UI. So this helps the user find the things he needs to work with. So instead of presenting 110,000 products, you can present like 200 icons, something like this. Polymorphism means then that this object or this icon, when you bring that out to the drawing, it can adapt and become many variations. And it also adapt depending on how you connect it, so not only in itself. So you combine it, we call it system configuration. There's a lot of configurators on the market, but they typically only configure a single product. Or they want to make an automatic choice for the whole thing. We just couldn't see this from the start. Can you imagine just setting up your constraints? I want an office with 10 cubicles and this and that and a reception area, and then you get an automatic layout done. You have no control over the output, no graphics, no nothing. You just lose control over aesthetic aspects and other human important aspects that are soft and fuzzy. You can't really make strong logical rules for them. So play, interact, and explore. Immersion. Immersion is a VR term, right? Virtual reality. You get immersion if you bring up a book and the book pulls you into context, right? Then you're immersed in there. Your mind is immersed in the action of the characters in the book. The same thing happens with an application that's well designed. If it's responding quickly, everything is flowing when you work with it, it's not hindering your work, then you're going to enter the design space with your mind, even if you just see it 2D. You don't even need a 3D for this. Your mind is going to be in the design space and thinking about function and work and whatever needs to be done to solve the problem for the customer that you're working against. So immersion is so important. And so that means if you think about immersion, anything that disrupts immersion is a pause, for example. It doesn't respond. Enough for a second, and you've broken immersion. You pop up a dialogue, you've broken immersion. There's so many ways of killing this feeling of that you're into it and it's just flowing for you. So just a couple of nice old examples. Here you have the condensed UI. So this little icon here is that one, the base rack in the kitchen. And I did an automatic little nested loops over width and depth of material, and output it as an array like this. And it checks each variation of parameters if it's a valid thing or not. So that icon creates all those potential products. So connection rules, yeah, we know that we are connected. We have a database of connections between objects, so we can do things. We can manipulate them depending on if you are connected or not. Really, I mean, this is like 93, 94 standards. So I hope we can develop this further, but I know that some of these things are not done today, and it frustrates me. So for me, this is really important that if you have like a desk this way and you point the cursor here, the heavy side should gravitate towards the cursor. And it's just kind of common that it's flipped the other way instead. So it's flipped opposite to when the cursor moves, and it feels really unnatural. So basic, but yet important. This auto distribution, have you seen this in CET? This is from '94, I think, when I did the Martela Finnish office furniture manufacturer. So you have a round table, and you have 3 chairs, and you come and you snap 2 more chairs in there, and it automatically distributes it around. Do you know how that would take place if you have a CAD system, a regular CAD system? We have to select the chairs, and then say pattern or something like this, and circular pattern, specify the degrees, and it just goes on, right? And for every change that you do to this. Reuse of information, you just have one shelf icon. This is another example of condensation, but again, when you come to the shelving base that you snap into, it will adapt to that, because there is no sense in having a too small or too large shelf in the shelving base. So it will just do that for you. Automatic calculation of floors and all other things that go under this type of component. And then higher level operations. This is, the architect's recommended combination of about 20, or maybe it's even 30 properties that goes about the quick kitchen. So you draw that kitchen up, but you say, oh, maybe I want it in a different style. And you browse the styles here, you just click on an icon, and bam, it does the complete change for you, and still checks that it's valid to build. So it's not going to create it unless you can really order it and price it. We do have a global connection database in our application, so we can do calculations if it's appropriate. This is a fume extraction equipment from a Swedish manufacturer. And when you do that, you connect a number of these to a central fan. The central fan needs to be dimensioned. The capacity required depends on the length and the number of bends and the usage, like frequency of these stations that you're creating. So it's called it's a pressure drop calculation that needs to be done for the whole system, and that's this curve here that comes. And these are fan capacity curves. So it even finds a recommended fan for you by looking at the meeting point between these. So I think when we came to this company, they spent a week on each pressure drop in Excel, and it's typically only one person who could do it. Now it's distributed to every salesperson. So that was a lot of just tiny little tidbits of PGC. So quality is the next part. I like this part because it's so fuzzy. It's the most fuzzy thing that you can think about. Quality. What is quality? When I was 20, I read this book, and it's still sharp in my mind. It's by Robert Pirsig. You see, Zen and the Art of Motorcycle Maintenance. Anyone read it? The book is about a person who he's a teacher, but he gets obsessed by the idea of quality. He wanted to define quality, and he goes in such a deep quest for quality that in the end he goes to meditation, to such depth that he goes catatonic and can't be revived with anything else than electrotherapy. You know, they throw current through your brain to reset it, more or less. So it's just so fascinating story. Just a little side thing is that, you know, I think it was rejected by 121 publishers and then sold 5 million copies when it finally got published. So it is a very gripping story. But this search for the definition of quality, it's more or less that, you know, he calls it undefinable. You can only, but yet we know quality. Don't forget that. Everyone knows what quality is. As a group, definitely we can come to consensus if something has quality or not. But it's what? It's a touch and feel. You have to immerse yourself into it to feel if it has that. It's a very, in a way, yes, subjective thing. PGC is exactly this. But we all know, I think, there are a number of principles that needs to be upheld for PGC, but it's quality-based, and we're going to know if we just shut down our brain and go into it and feel it. So why did I put Kung Fu here? Kung Fu is fighting, right? No. Kung Fu is actually a general term where Kung means hard work and patience, and Fu means excellence. So any activity where you take that extreme mindset of you're ready to put in the hard work and you're ready to have patience to achieve excellence. And that goes for that. And that's sometimes something you need as well to create a good PGC application. Good enough is probably the opposite of quality from my point of view. Is one of my hate terms. It really goes way, it's absolutely the opposite of excellence, I think. If you haven't tried this website, I recommend it highly. If I go there, I almost die laughing. I mean, he poses as a web designer, right? And many people seem to take him seriously, but I think he just made this, you know, to give, because he's seen so many bad examples of design on the internet in HTML, so he's just portraying all the bad examples and make them even worse. How about the starting picture? You click on the airplane and you get into the site. And you get into the site, and this is the Bud patented navigator. You try that and you will not stop laughing, because you move here in the menu and it will like randomly pick something else where you're not pointing. It's absolutely great. So, why should we care about going for quality and excellence? Well, I think the biggest corporation in the world is Apple right now, and it's built purely on quality, and it was built by this man, right, more or less, because he was fanatic about quality. I would expect him to have been a dictator, because you really have to be strong. Most people don't want to go all this way, you know. They don't want to be there. It takes a lot of effort to get to this quality level. But I mean, it's not a little success we're talking about, right? It's fascinating as well, because the computer on the left is the first serious computer I had and started to work on. When I was 14, I did the first calculation application for my father's interior wall business, where you could input a number and an article number, and it would bring up the description text and the price and multiply that together, and then just go on to the next line. So you could quickly fill in the order. This was done in a computer with 48K of working memory, 48 kilobytes. So I could not fit the 120 article database in memory. It did not fit. 120. Things has changed a little since then. So I put it on the floppy disk. You know what a floppy disk is? One of these soft magnetic things. It was really slow. You could hear it work like zip, 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 like this. So how can you find the information? You can't then scan through 120 items on a floppy disk. It's going to take 5 seconds, 10 seconds. So without having any idea about the concept, I invented binary search. So I sorted them and I saved them to the disk. And then I start in the middle. I look if it's smaller or bigger. And I jump to the next half, and you half, and you half. So it becomes a log 2 of the number. So so you could actually hear that go when you put in the article number, you hear it, zip, 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 and it found it, and it came out. So there was a little delay, like half a second, but then it had the description text and the price. Kind of cool. Well, I'm enormously impressed by what he has accomplished, because if you look at it, it's a series of high-quality user interfaces. The Mac Classic was a big inspiration for PGC with the Mac Paint and the right from the start. And then like the pad, or sorry, the pod, right? And even like the latest one, the Apple TV, they're all, it's just such a fantastic journey. I think his father was a carpenter, and he taught him to, even if he builds a cabinet, even the backside needs to be high quality wood. And the lesson was like, just if nothing else, because it makes you sleep better. So it's like quality driven all the way through. The Mac Classic, the one in the middle, it's really hard to get into. You have to have a very long Torx special tool to get into it. But if you get into it, everything is enormously neat, beautiful. There are signatures of the designers. But clearly, it was never meant to be looked at by a consumer. But it was designed to perfection. This just shows you how far he was ready to go for quality. So, have you unboxed an Apple TV? It's just fascinating. There's quality again. The packaging is quality. But then you get to this part, unless you have an iPad when you do it. This is one of the worst examples of UI design I have ever experienced in my life. What's the worst layout for a keyboard? It's linear. You could at least do it square, whatever. I mean, why not QWERTY? Everyone uses QWERTY nowadays. So more or less everyone is familiar with it. So it's not a big deal to find that where's the letters around that. Now, I just don't get it. So maybe this was done after he left the ship. So I have no idea. Just a guess from me. TCQ, time, cost, quality, traditional management ideas, right? So you have to choose two. You can get quality if you spend a lot of time and it costs more. How about software? What is software production about this? This simply is not true for software. Quality is the only way to bound time and cost. If you don't do quality, it's going to become a complex mess, and it's going to cost you a fortune, and you're not going to get a very good result. So exactly that. So let's step back to the idea of a user interface. You can go to the university and take classes in user interface design. You learn probably about human psychology, that you shouldn't have groups of more than 3 or 5 and stuff like this, and have clear distinctions between them. But this is more or less nonsense for me. It's sort of not really very important. And because the problem is really here. It's the conceptual design, the model. And I took a car here because it's a user interface. It has a user interface, right? When you drive a car, and we're also overly familiar with it. But it's fascinating how the little gadgets of wind wipers and speed control and all this. Some of this is really non-standard. It varies with every car. I don't know if they do that intentionally to try to bind you to a brand or not. But it's sort of odd that after 100 years you couldn't standardize, how to start a wiper. Sometimes on the left side, sometimes on the right sides, it might be 2 knobs or 1 knob, etc. So fascinating again. But people who drive a car has to have, it's a very indirect system, right? You have lever here and a gear change here and some pedals here. It's really indirect, so you have to understand the connection between these controls and the conceptual model of what the car is. So you push that and the car goes forward if that is in lock, right? It's a conceptual model. So if your conceptual model looks like that, our picture of bad software, okay? I had it made by a summer intern this summer. If the conceptual model is really messy and confused because the programmer wasn't very clear in what he was doing, he was using his intense concentration and a lot of trial and error to get somewhere near the result you wanted, then how can you make a UI clear and understandable? It doesn't matter how pretty your icons are or how good your grouping ideas are. It's not going to be there. So the real work of a good user interface is under the surface to get it right. And again, this requires, of course, that you get up to the surface with whatever you try to do And so you get to touch and feel it. I always recommend people to cut their corners as quickly as possible to get to the goal where you can try it out. If you don't try it out, you will not know if it's successful or not. And then you spent all this time investing in the system created to try to make something that fits your idea. But it didn't feel right in the end, so it's all waste. But then you have this emotional connection to the code, and you're reluctant to throw it away. So let's try to connect all the way over to programming style. And style, quality again, right? Isn't it? So why do we need that? Programming is a strictly logical process. Don't you agree? The more I work, and you should go and listen to Magnus as well, because he's even more emotional programmer than I am. It's more like, we have no idea what we're going to do, but when the fingers touch the keyboard here, it starts to flow out. It's like the ideas are already ready. Of course, you need focus and concentration and problem understanding. You try to understand the problem before this happens. Maybe it needs rest in between, but then when it happens, it's a really strange and sort of just quality-based process. So, trying to describe programming for non-programmers, I did it this way. Programs are built from language definitions. So as humans, we use language to describe problems. To get anywhere with that, we need the language to be precise, consistent, and orthogonal. What does that all mean? Precise means that we need distinct terms. We don't want any overlap, so orthogonal means they should be as distinctly different as possible as well. Then it will be easy to understand what each word refers to. And consistent means every use of that word should be the same throughout the system. That requires a lot of discipline, of course. If you do that right, then we can describe large systems without creating that type of mess that we were just looking at. It doesn't take all that much effort anymore. But imprecise language quickly increases this effort to, it's like it's going to completely consume all conceivable resources. So even if we double the team of programmers, it's not going to help. And it very typically creates, because maybe that's why it's called program code. Code is a crypto, right? Something you're not supposed to understand. It's fascinating. Maybe this is because in the early days we were programming in hex code, machine code, all the way down to what the processor needs. But today we're not. We're designing language to create our programs and build our systems. So we should try to make them clear and concise and simple as possible. And then we don't get all these unwanted side effects when we need to do fixes or changes. So my secret, well, I think I stepped ahead. But I will tell you my secret. This is from my lifetime of programming. It's over 40 years now. But you will be disappointed. Why? Because there is no fantastic, complicated super answer here. It's just simplicity. That's it. That's what I've been saying now. I have trained my brain for all my grown-up life since, programming since like I was 11. So I can deal with a lot of complication, and sometimes I have to, because it's just there in the system. It's being created by multiple people or whatever the reason is. But I don't like it. It's a waste of time. I am enormously good at debugging. I have, I think, around 40 different attacks to find problems. So I don't waste time when I debug. I'm really, really highly efficient, but I try to avoid it entirely. That's the best debugging. Don't do it. So you design it away by doing simplicity instead. I want it to be so dead simple, so it's trivial. Then I'm happy with the code. The times when I manage to write modules that are that clear, I usually get 1 or 2 issues back from the initial release of it, and then never, ever anything more. Rolf is going to present the task system later on, and that's a good example of exactly this. I never had to go into that code again after that. And it has a very central role in our system to do background things for us. So how do you achieve simplicity? Yeah, it's language precision. This is my own words. The more precisely you can define your vocabulary used to describe the problem, the easier it becomes. So, and how do we go about this? Yeah, well, if you're not an advanced programmer, you should try to discuss your problem with an advanced or experienced programmer before you start. Before you start investing in your own solution, try to get the concepts and the wording right, the basic pattern, the basic idea of solving it right with his experience, and then take a shot at it for a day or for 2 or for a week, and then go back and ask, do you think this is cool or not? And maybe you get good feedback or not, because I mean, it's sort of hard from the outside. It doesn't matter how experienced you are, because you have to immerse yourself into it. But if you haven't complicated it, if it's still simple, then you're going to get feedback. But it's really easy to go complication from there. So again, precision. Natural language isn't very precise, and we're not very consistent with using it. But as human beings, we get away with it because our brains are such fantastic pattern matchers. So I just want to give you a little. This is another piece of my favorite literature from a guy called Wittgenstein. He wrote something called Tractatus Logicus Philosophicus in a prison camp after the end of First World War. Can you imagine? One of the most important pieces of philosophy in our century, and it was written like that. Well, he thought that things like paradoxes and other philosophical problems came out of misconceptions of natural language. So he set out to solve that. So I just love this because I can see don't you use a to-do list when you program? I have like F2, I jump to my to-do list. I can write in stuff I need to do, you know. So when I work, I see something, that would be nice. But instead of stopping what I'm doing, I just put it in the to-do list and I can let it go for now and I can get back to it later. So he put in his to-do list, solve all philosophical problems. And then he spent a number of years of writing this book. It looks like this. and then he left philosophy for 8 years. Can you imagine? 8 years before he came back, because he thought he was done. So go to the to-do list and say, done. I just love this. And now we just have to read a little bit. This is so beautiful. The book begins with, the world is everything that is the case. And in German, of course, die Welt ist alles, was der Fall ist. Anyone study German? And the ending is even better, you know. Whereof one cannot speak, thereof one must be silent. So the world is just a composition of facts, etc. I mean, it's like a propositional logic definition of language and the world and how they connect. And then in German, wovon man nicht sprechen kann, darüber muss man schweigen. It's poetry. Pure poetry. So programmers again are these spellcasters, these wizards, right? And they create this fantastic code. Don't you love this? Define, I just grabbed this picture from the internet. Define 0, corrupted. 0 is the cleanest concept I can imagine, not corrupted. So, well, so you train your brain all your life. If you're a programmer, you become very smart. And people probably are quite smart when they are attracted to programming because it challenges the brain continuously. So this cleverness actually works against many programmers, or most, I would say. They don't see complication as a problem. They see it as a challenge. It's fascinating. So they just thrive in that rather than trying to get rid of it. And then when you, in the end, you with a lot of trial and error and effort, you fix your bug X357, you're so proud. This, especially exactly the thing I was talking about, the to-do list, is trying to avoid this problem subroutine jumping, that you're sitting in a problem and you see a new problem and you go into and start fixing that, and you see a new problem and you do that. It's like it's smaller and smaller. And then you've done that 5 times, and it's such a small problem compared to what you set out to work with, so no one will ever care if you solve it or not. But it's very typical. So this is what we mostly do, right? We write code that looks like not good. I call it a prototype. I'm not going to go through this. This is a full lecture by itself. This is just a little extract of it. But a prototype is, I call it the lowest value of programming that you can produce, because it's a messy piece of code, doesn't have any real reuse in it, and it's complicated. So it just doesn't have the things that we are looking for. So instead of using simplification as your fundamental method, it's intense concentration mixed with trial and error, lots of trial and error. Maybe it even starts worse with copy and paste. So you take a piece of code which you don't properly understand because it was written badly, you copy that and you start to twiddle with it with trial and error and intense concentration to try to make it do what you want. And in the end, you're sort of successful. This way, bad code spreads throughout the system like a virus. And then you get 5 copies that are slightly different, and you're going to sit there. Did you play this child's game with pictures, and they're slightly different? You have to find the differences. This is exactly that. So it's a mind-bogglingly waste of time. So what happens when you tap a programmer on the shoulder? He spent so much effort to get into this focus, so he gets angry, right? You wake the bear up. So we add. The system initially grows fast, functionality comes up, but then it evens out because we spend more and more time debugging, and speed response just dies out because we're too much focused on adding stuff to the system. And you ask programmers, they say, I don't have time. Of course you don't have time, because we add stuff to create complication and you spend the time debugging, so we can't have time. It's just a mind lock. It's a bad mind lock. You have to get out of the mind lock, and only that is just getting the vocabulary exactly right. Design that conceptual machine simple yet complete. Do you know who the gentleman is on the picture? Einstein. What did he say? What is the citation there? Everything should be made as simple as possible, but not simpler. So, thought of as a primarily logical process, I say it's a very quality-based and emotional process, and this is the important step of programming. So it's the absolute opposite of complicated problem solving. It's trying to make it as high quality, simplified perfection as possible. And then if you do this, I just noticed throughout my own years, because I used to be that intensely concentrated person, and it would take me half an hour to get back into context if someone tapped me on the shoulder. But nowadays, this is what you get if you tap me on the shoulder. I'm hardly disrupted at all. This is my puppy, by the way. Oh, you kid. That's not angry, right? That's cute. So that's what you want. This is a role model, because if someone comes into your room, yeah, if they repeatedly come and disturb you because they're lazy, they don't want to think for themselves, then it's not okay. But otherwise, I mean, we have to communicate, we have to teach, we have to be outward. That's what good is. So quality is the highest level, right? And it rests on good design. But we need performance. If we forget performance, the quality is not going to be there. Then we're going to sit and wait and be disrupted. And this all will compound the cost rather than the opposite. Everyone think we don't have time for this, we would love to do it, but we can't find time for it. Well, there's only time can be found this way and no other way. So, right? Give in to anger. Anger leads to hate. Hate leads to suffering, right? So, singular function focus. The pressure from the outside on a software developing organization is enormous to add this, fix this, I need this feature. There's an endless list of features. I think we have 6,000 or so in the queue. They're never going to end, but even if we fix all 6,000, there's going to be 6 new more thousand. They're probably going to be much smaller in dignity. But the human mind is just made that way. We can forever zoom into a smaller and smaller problem and say, now that's the most important thing. So it's not going to end. And that pressures you into singular function focus. And then you forget about performance, you forget about quality. It gets pushed out because we don't have time for it. And that leads into a bad situation. Because in the end, performance is even going to stop programming, right? Because programmers are waiting for the system. Even if we have the fantastic CM programming, I don't mean to say that, but even if we have a programming language that is incremental and instant to change in, but we still have to wait for when it's running, we're still waiting. We're wasting our time. Why did Configura come up with a crazy idea to create its own programming language? Why would you set out to do that? It's not something you're supposed to do. And I didn't even take the compiler course at university. Pardon?
The others weren't good enough?
Exactly. I was tired of waiting. So when Johan and I sat 92, 93, we had 30 seconds when we started the project. There was functionality kept growing, and the code base kept growing. So even with faster machines, we got up to a full minute turnaround to add a print, a trace into the code. How many times do you add a trace in your code every day? Hundreds, right? So it's hundreds of minutes just gone. And then your programming style becomes, you have to sit there and think for a long time before you commit to compiling it. But then you're going to have multiple errors to resolve, so it sort of brings you out of context, and then you get it to run in the end. And then you have to get into your test context, might be opening a dialog or whatever, and then you can see if it has the expected effect or not. This is a very slow and burdensome process. No wonder it takes time and costs a lot of money. But if you have an incremental language, it's instant. You never leave your context. You have the dialog open. You just make a change, and it's instant. It's there. This is so easy to work with comparatively. And then it happens that this is used to create systems that are so slow to work with that all the benefits are gone. It just fascinates me beyond belief. So countermeasures. We want to be design-based rather than function-based in our organization style. So that means we have a primary vision, which is PGC. And whatever decisions we make in our extension or in our core application has to be evaluated constantly against this primary vision. Coaching is something I'm starting to implement at Configura. So we want to have the best people, and maybe even the next level and the next level, continuously go out and actively coach a number of other people. We're not going to just coach, so maybe I will select 3 people which I go to. But for some reason people have different restrictions of if they want to come to me or not, and many people don't really dare to come to me, so it does not happen. So I think right now that I will just mechanically schedule, I'm going to go there. So I have to go every week to these persons that I think are worth to lift up. And those 3 people can take 3 more. And then we get a coaching organization where instead of locking in the knowledge in specific people, we can spread the knowledge and push it downwards to make everyone as good as possible. And then also to leverage all my experience in the design that goes into these 3 people, and then can keep teaching that out. So, strong encouragement for code improvement. This really goes against all maintenance ideas, because when you have a complex system, especially if you have a complex system, everyone is dead scared to touch it because it's going to break, and you get blamed for it. It's not a good situation, because then you're not going to evolve your software anymore. So we want to encourage code improvement, and we rather need a Toyota mentality than that if something breaks, then everyone gets interested in helping to fix it instead of putting blame on the single person that happened to be the culprit for this specific thing. Yeah, we have all these systems, so we can find who committed the change. Oh, you're at blame. Put a poster up, the crook of the week. You're not going to get a good culture for that. So make an encouraging culture instead and help people improve code. Schedule performance focus. I was talking now about the quality and performance gets pushed out because we have so many things to do all the time. So I think we have to schedule. We have to allocate time specifically for these tasks. Dematic, I know, for example, have 2 days out of 2 weeks for every sprint they do. Is solely on performance right now. And that's really good, because they are ahead of me. They implemented it. I do appreciate that 100%. They are sort of forced because they have the biggest drawings we've ever seen. Quality goes with the same thing. Initiative time, what's that? Well, the idea here is to open up a time slot for the programmers as well. to choose what they think is the most important. So instead of trying to control everything from the top, managers saying, you have to do this, and oh, the task is complete and you have to do this, then you say, do whatever you want now for a day if you think it's important. And then tell us, you have to show the group what you've accomplished as well. So it's not like free time to go out and do whatever. I mean, it's supposed to add value to the system, but bigger value because you have an insight that maybe someone else doesn't. So that's the initiative time idea. Measure activities. Take a look at, when an organization grows, the number of emails that you have to look at, or read through, or spend time with answering just grows. Sometimes I feel this can kill all your time. So personally, I have periods when I just ignore the inbox, more or less. I take a second at most to look at each one if it's an emergency or not. The rest I just let be there, And then maybe a week later, I go through the whole thing. But measuring this activity is what I mean is important. Measuring the number of meetings, the time spent on meetings, and then start reasoning about optimizing. Can we be few people in the meeting? Is it really efficient with 12 people? Maybe it's only 3 people talking. Why do we need 12 people in the meeting? Is it the general information? Maybe then we can instead have a summary meeting with 12 people and just give out the information quickly. That's an optimization, right, of an activity. So these things just tend to grow and bloom out and then consume more and more time, and it becomes less and less efficient. Because as a programmer, you love to code and solve problems, not sit in meetings and do all the other stuff. And number 9, managers must role play, being users. This is mandatory. I think there is a generation problem right now that managers are around a little older than I am, so they did not grow up with computers. It's typically 55. They don't like computers, they don't really understand them, so they typically avoid it to not show that they're not good at it. So they try to push it out, and this gives you this strange information break, because the whole thing I've been talking about throughout today is touch and feel. You have to sit there, and you have to touch it, you have to try, you have to become a user, at least for 10 minutes, to understand if the application is good or not. Oh, I can't do that. Everyone can do that. It's ridiculous. You take the mouse and you try it out, see how it responds. Well, I think it says anyway. Continuous improvement. Yeah, we want to encourage programmers to get good habits, and that goes from everything to programming style to taking care of their health. So we also do that quite a bit at Configure Out. So we implement different programs to encourage people to do exercises and things like this. If you're not strong physically, I mean, your brain rests on your physical status, so you're not going to be strong mentally. Simple as that. If you're really strong physically, then you have a good chance to have a longer stamina for what you're doing. So this is what happens if we don't follow the principles, right? So this is from the same artist. And this is where we want to be, a well-structured, clean and clear system and a good process for adding and changing it that's controlled. Probably you can get happy users and good quality from this. All right, do you have any questions? Any ideas, something you want to talk about? Was it overwhelming?
A lot of work to do.
Pardon?
It's a lot of work to do.
Yeah, it's a lot of work to do, absolutely.
It's beneficial.
I mean, trying to go into the next problem with a quality mindset instead of just getting it done as quick and dirty as possible is very, very different. I have no problem with quick and dirty if it doesn't stop you, but for me it's usually when I pass 20 lines I start to structure. You know why? Because otherwise I spend time debugging to get even to a quick and dirty solution. So structuring the problem as I go, even if I'm going to throw away the whole thing, because it wasn't a good idea, then it still saves me time. So that's the quality approach to getting to the goal. But my first golden rule of programming, if you've seen that, is get to the goal as fast as possible. Get to the goal as fast as possible. Because if we haven't tried how it feels in the user interface, we do not yet know if it's a good idea or not. And when we're up there and we try it out, we get the PGC feeling of it. This was good. Let's do a full attack on this. Can we do a different approach? Do we need all these data structures to support it? Can we do it with an engine instead? Or which way are we going to do this? Then step back, reflect, and try to do a clean solution for it. The cleaner solution, the better. Yeah.
I think I asked this question. Are you seeing more success with programmers learning product or product managers learning programming? So we're having a challenge with, I'm thinking through, we have a product that's in the marketplace and we're having programmers design how to specify it, and it's kind of this, do this next feature, fix this bug, and I feel like our product managers are not understanding what the tool can and can't do, how to coach. And so are you seeing more success with many of your customers or your...
Yeah, like I say, I feel there's this generation break, and it's going to resolve itself in like 5-10 years, because then the people are going to have grown up with computers, and so the managers are going to be tech savvy enough to do the right decisions. But if you're just pushing, if you're just managing like this, you have your bug tracking, you're taking out these little features or fixes that needs to be done, you push it to a programmer, and you think this is efficient, he goes in and he does his shot from the side. It's like chopping down a tree from the side. You don't do design-based. You drill all these little holes, and no one takes care of the overall quality. No one even cares anymore. Everything gets like acceptance. So even if every little change just adds a few microseconds, in the end, the operation takes seconds. And no one is to blame, right? It just happened. But it happens because we do not keep to that principle of keep evaluating against quality all the time. Something else? Yeah.
I usually trying to teach the fact that you should solve problems rather than removing symptoms.
Mm-hmm.
And this is actually quite difficult because if you get a ticket, I mean, we use
Yeah.
tickets as a description of what should be done as a program. And it describes a specific scenario, and it's this and this happens, and this would be the expected behavior.
Yeah.
It's unfortunately not very common that a program takes this, solves that specific thing through a number of if statements even.
Exactly, just adds complication.
And then what you have, when you test it, it works fine. But the change should probably have been on a different level.
Yep.
And
then
it
it
needs to be taught all the time that you need to raise your
awareness, yeah.
awareness bit and make sure that you understand the whole thing. I mean, we're talking about an object-oriented system. And
Yeah, and maybe many other similar products as well,
Yeah.
which now don't behave the same way.
if you see this is a problem, okay, does this go for all products like this, or is it this specific one? Then it may fix that.
Yeah.
So, but that is very difficult to teach.
Yeah, well, I don't think it, yeah, but it's especially hard when you're building your system around, or your process around the Scrum and bug tracking systems, because it just takes away your focus from the overall picture. So I'm not very, it's a useful management method, but I'm not very fond of it. So it should only be used in time bursts, I think. Otherwise, you should work differently, which is that, design-based. But when you close up to the release, I mean, it's a highly efficient method. So, a few more questions, and then we're out of time. Or maybe we're done.
I have a question.
Yeah?
There's a saying, and the saying goes, preemptive optimization is the root of all evil.
Yeah.
You talk about you add a millisecond here, you add a millisecond there, and at the end...
It gets slow, and then you should attack that. Well, I don't like that. The saying I don't think is very bright, because usually when I start with a problem, the first thing I think about is what happens if there's 10,000? Well, you did a quadratic solution, it's going to do 10,000 times 10,000 operations to get there. If it's a milliseconds each, can you count? 1,000 times 1,000, so it's 100 million, right? 100 million milliseconds. So it's 100,000 seconds, right? It's not very good. It's kind of bad. I think it's kind of clear in my world when I need to optimize or not. And so if it's important, if it's in the critical path, Yeah, you can fudge it from the start. You skip that problem, but you know it's important, so it's on your to-do list. Fine. So that means you cheat on some part just to get to the goal. That's fine. But you know you're going to have to optimize it. You can't just skip it. Otherwise, if you're inexperienced, maybe you don't understand that this is going to be a problem. But I see that this is little like Rolf's statements there about awareness, that the first thing I think about, what happens if you scale this up, if you get many? Because that's really important to me, performance. I want it to be snappy and give good feedback and be fast, quick for the user. So I think sometimes I do optimization quite early, almost from the start, because I already know it's critical path. It's going to be important. And if I do a bad solution, it's going to be really slow when you go big.
So I am just correlating gentleman said whether the product owner, product specialist should learn the language and then get the things done better way, or the programmers, good programmers should learn products and then implement them better. So I think there is a balancing thing here.
Yeah, absolutely.
One, because if product specialists are supposed to learn, that's why all these automation scripting things have come up, so that
Yeah, I mean,
just
product specialist is never going to be that good at programming, so he's not going to be the same as good at, for a programmer, it's very natural to generalize, to make these condensations and that type of stuff. It's just, you do that all day long. But for a product specialist, maybe he does one icon per product. It's just a typical solution, because from his point of view, it's not natural to do the generalization. So you really have to have a mix of both, I think, because the product, of course, the programmer is not going to be as good at product, especially if the product is very complicated. Well, I don't know. My personal experience is with what, kitchen, office furniture, and shelving systems. I don't do customizations anymore. I used to do it quite a bit, but I don't get the luxury anymore to sit there and do direct things in the UI. But another side to, if you go quality-based like this, is that the programmers, I mean, it's really important today to keep the best guys, right? If you give them a bad work environment, they're going to go somewhere else, don't worry. So giving them a stimulating work, which means go for quality, they're going to like to work for you. So you give them these boring little fixes, and they sit there and they know we're going to destroy the quality. Who likes to do that? You go home and you know you haven't, the totality is worse. So I think there are many sides to these ideas that are important. And it's a very competitive world for programmers today. And we all are software development organizations nowadays. Yeah?
I guess you could say, well, I would have asked the question in a different way. I don't think the product specialist should learn programming, but they should learn the sort of basic, the fundamentals of programming.
Yeah.
Organize behavior and then specialize as long as we come down to the final product. I mean, if we have a product line, it should be, all the general behavior should be in one place, and then we should divert it.
Yeah, there's a clear overlap between the two skill sets. So I think if you work together and both learn from the other, it's going to be a better result. Absolutely.
So if you're able to teach the product specialists these basic concepts of how programming works, not the syntax of the language.
No, but that's another thing that we've been using from the start, is that we often get presented with solutions. They want a specific menu or a specific button, a specific thing, but then we just try to continue to ask questions to understand the real underlying problem. And then we come back with a solution that's a complete surprise to the customer. This is not how we envisioned it at all, but it solves the problem so much better. So this is again going for quality. Yes?
Just the half part of my equation was incomplete. So when we go from the programming perspective, when we say it should be design based, then I think there are some commitments to be very, very well respected. Is what is my design, how it evolves, when interface commitment changes, how well it is respected from all the sides. So this design-based philosophy really defines some fundamental guidelines which have to be not ignored at all.
Yeah, it's a little bit like that, yes, absolutely. Okay, I think we're capping this. Thank you for your attention.